Hi everyone, welcome to my channel, Tutorly Test Prep. Today we'll be going over Ottocento number 9, Basic Statistics. The goal of the Ottocento course is to teach students everything they need to know about the digital SAT math exam. Please see the link in the description to download this video's worksheet for free. Let's get started. Okay, so first thing we need to talk about is sample size. We've talked about this in another video before, but just a quick overview. So sample size, we use lowercase n, not to be confused with population size. N is the number of data values in your data set. It's also the number of participants in your study. And those first two are pretty self-explanatory. What lots of people tend to forget is that n is the sum of the frequencies. So we might have to add up some frequencies to figure out n for some problems, as you'll see. Okay, so these are probably some of the most important things in this entire video, so the mean and median equations. So to calculate mean, we do the sum divided by n, and to help us find the median, we use the position of median formula. The position of median is equal to n plus 1 over 2. Make sure you know both of these like the back of your hand going into your exam. All right, so skill number 1, mean of a list. So first I count, and I see there's 1, 2, 3, 4, 5, 6 data values, so n is equal to 6. Next, we are going to use the equation, so mean equals sum over n. 4 plus 7 plus 9 plus 10 plus 12 plus 24, that's our sum, and n is 6. You should get 11 if you put that in a calculator. Understanding this is important for the problems we're going to do later, but just keep in mind a question this simple you could do straight away on Desmos very easily. Okay, skill number 2, median of a list. So first thing we need to do, this is really important guys, we need to put the data in order. So I think it's 5, 8, 12, 16, 100. I see that there's 5 numbers, so that means n equals 5. Now we're going to use the formula n plus 1 over 2. 5 plus 1 over 2, that's 3. And the 3 tells us that the third data value is our median. So now we're just going to count to the third number so long as it's in order. 1, 2, 3. Okay, the third data value is 12. So the median is 12. So that's what you do if there's an odd data set. For an even data set, first, once again, we're going to put them in order. We count, I think this one has 8, so n is equal to 8. Then we do n plus 1 over 2. 8 plus 1 over 2 gives you 4.5. Now this is really important. What you do is, think of it this way. 4.5, what two numbers is 4.5 directly in between? Well, it's directly between 4 and 5. So we're going to find those two values and we're going to average them. So we're going to take the average of the fourth and the fifth value. So now we count 1, 2, 3. Okay, the fourth value is at 24 and the fifth value is 29. To average two numbers, all you're going to do is you add them up and divide by 2. So the median is 24 plus 9 over 2, which is 26.5. And of course, you could do these problems very easily on Desmos. This was just to teach you guys how these equations work so that when we go to do harder ones that maybe we can't just do right away on Desmos, you know how to do it. So practice doing it by hand and practice doing it on Desmos as well. Notice how this saved us a ton of time because we didn't even have to put them in order. We could just type them straight into Desmos in the order they were in. Okay, large data sets. So take a look at this list of grades on a math test. And I'm going to put this in this bar chart. It's not a bar chart, but I'm going to put it in this chart. And the values are on the x-axis and the frequencies are on the y-axis. So this is called a histogram. So whenever I see a histogram, first thing I do is I write the frequencies on top of the bars. So 2, 3, 5, 1, 3, 2, just to make that easier so I don't have to keep reading the graph over and over again. And as we said, the x-axis is always going to be the value, and the y-axis is going to be the frequency. So why am I doing this with you guys? This is confusing for lots of people, okay? So those frequencies are not numbers in the data set. You see, right? 2. There's no 2 in the data set, right? Look on the left. There's no 2 in that list, right? It's telling you how many 70s there are. So you see there's 2 70s, 3 75s, 5 80s, 1 85, 3 90s, and 2 95. That is what the histogram is telling you. That's what a frequency represents. If you put the median for this one is like 5 or something, you know that that's wrong because there's no 5 in the data set. Okay, great. So that's a histogram. And if you wanted to find n, you could add up all of those frequencies, the red numbers, and you would get 16. And if you wanted to, you could go and put these guys kind of in like a cumulative distribution like I did on the bottom. So like the 2 has the first 2, 1 to 2. Then 3, 3, 4, 5. Okay, 3 through 5. The next one has 5, 6, 7, 8, 9, 10. Okay, 6 to 10. You could go through and label it like that, and that's what some tutors like to do. I really don't like doing that. I'm just putting it here for the sake of teaching. I'm going to show you guys an easier way to keep track of the position, at least that I think, when we go to do an example in a minute. So that green stuff I wrote there, not that important. Okay, another way to display a large data set that you will see all the time on the SAT is a frequency table. So not always, but the vast majority of the time, a frequency table will have the value in the first column and then the frequency in the second column. Regardless, remember we talked about n is like, frequency is like the number of participants. So like number of students, number of voters, number of turtles, number of dogs, whatever you're studying. That whatever sounds like that is going to be your frequency. And then probably the other column is going to be your value. But as I said, usually value is on the left, but it's not all the time like with histograms. So just pay close attention. Anyway, so what I want you guys to understand is that this is just displaying the exact same information. Nothing is different. So everything I'm about to teach you for both calculating the mean and calculating the median from a histogram and a frequency table, they are both the same. It's the same information, just displayed differently. So don't let either of these two things confuse you. They're the same thing. It's just what's nice about the histogram is you have the nice picture to look at, which can help you make sense of maybe how the data is shaped, which maybe the frequency table doesn't give you. Again, not important for the SAT. We're just going to do calculations. Okay, so skill number 3, mean of a large data set. Oftentimes in the question, not always, but a lot of the time, they'll tell you the sample size in the question. So do you see how it says 16 students? We didn't need to go and add up all those red numbers. We could just write down, okay, n is 16 because they told us. So if you notice that, that'll save you some time. Anyway, so mean is sum over n. So n is 16. That part's easy. The sum, this is the part that confuses everyone. What you're going to do is you're basically going to go and find the area of all these bars and add them up. So watch what I do. 2 times 70 plus 3 times 75 plus 5 times 80 plus 1 times 85 plus 3 times 90 plus 2 times 95. So that's what you type in for your sum. You can do it all in one go on Desmos. You don't have to put parentheses, but I highly recommend you put them just because it makes it easier for you to read so that you can see what you're typing. And of course 16 we put on the bottom. So that sum, if I did it right, should come out to 1310. And 1310 divided by 16 is 81.875. So the mean for this one should be 81.875. So you see, you just multiply, add, multiply, add, multiply, add. We're basically finding the areas of the bars. Okay, now we'll do the mean of a frequency table. So this one, they don't tell us what n is, so we really got to go and add up all those frequencies. Remember, n is the sum of the frequencies. So 4 plus 3 plus 2 plus 6 plus 1 plus 5 plus 2, that gives us 23. We're going to do the same thing, mean equals sum over n. And n is just 23. The sum, we multiply and add, multiply and add. So these guys all go together. 5 times 4 plus 8 times 3 plus 9 times 2 plus 14 times 6 plus 16 times 1 plus 19 times 5 plus 23 times 2. You should get a sum of 303. 303 over 23 should give you approximately 13.17. Great, let's do the median now. Same thing, n is 16. And we're going to do the position of median formula, n plus 1 over 2. 16 plus 1 over 2 gives you 8.5. 8.5 is smack between 8 and 9. So the median is going to be the average of the 8th and 9th data values. Now, you don't need to go and find a distribution like I was telling you guys about before. We can just go and quickly figure out where those numbers are just by doing addition. So watch what I do. All we're going to do is we're going to cumulatively add the frequencies until we reach or exceed the number we're looking for. So we're looking for the 8th number, so I'm going to add until we hit or exceed 8. So watch what I do. 2. Okay, that's not 8. I got to keep going. 2 plus 3, that's 5. It's still not 8. Got to keep going. Okay, let's try the next one. 2 plus 3 plus 5, that's 10. Okay, ding, ding, ding. We're going to stop because we're bigger than 8. And as a matter of fact, we're equal to or bigger than 9 as well. So both the 8th and the 9th numbers are 80. And we kind of got lucky. The average of two identical numbers is just that number. So the median is just 80. So you'll notice for even data sets, when you see these on the SAT, a lot of times they'll just both happen to be in the same bar and you won't have to do any work. But just be careful because you might see one where perhaps maybe, let's say in this one, the 8th one was the last 80 and then the 9th one was the 85, in which case they're different. So you have to actually go through and add them up. Divide by 2. We didn't have to do that here because we got lucky they were in the same bar. Okay, great. Okay, for the frequency table, we're going to do the exact same thing. So n is 23, just like we talked about before. And now we're going to do n plus 1 over 2. 23 plus 1 over 2 is 12. And we're going to cumulatively add the frequencies until we reach or exceed 12. Okay, so 4, it's too small. 4 plus 3 is 7, still too small. 4 plus 3 plus 2, that's 9, still too small. 4 plus 3 plus 2 plus 6, that's 15. Okay, we stop because we passed 12. We're bigger than 12, greater than or equal to 12. So we're going to stop there. And it's not 6, guys. There is no 6 in this data set. And even if there were a 6 in this data set, that's not what the frequency is telling you. The mean and median we always get from the values. So the median is 14. You would hate to do all that work and put down 6, which is wrong. Okay, the median is 14. You got to look in the value column. Okay, great. Let's keep going. All right, so something you need to know about histograms, and you're going to see these on the SAT, is that the bins don't have to represent a single value. They can represent a range of values. So what we're going to talk about is how to read histograms that are like that and make sense of them, because they've been asking some rather abstract questions that require you to know how to do this. I call this the include left, exclude right convention. So they don't have to be integers, but you'll see a lot of times on the SAT, they'll tell you that the data values are integers because they don't want to overcomplicate things in that sense. So let's just say these are integers. And do you notice how some of those numbers in the middle, like 75, 80, 85, we're like, wait, which box do those go in? Like, are those in 2 boxes? So that's where this comes in. So let's label these boxes 1 through 6. Box 1, we include the left, exclude the right. So box 1 could have 70, 71, 72, 73, 74, and then we exclude the right side, so 75. So box 1 could have 70, 71, 72, 73, 74. Now we go to box 2, and we go, okay, include left, exclude the right. So now we pick up at 75, 76, 77, 78, 79, and then right before we get to 80, we stop because 80 is not in that box. Then in the next box, we pick up, hopefully you guys can kind of see this now. Okay, look at box 3. left, include the left, 80, 81, 82, 83, 84, exclude the right. And you can do that for all these boxes. And this is going to be important for some questions we're about to do. And College Board will tell you all this in the exam, but it's going to be like 2 or 3 sentences of just garbage that just aren't going to make any sense. So it's really better if you just understand this going into the test. Even though it'll tell you in the question, it's really not going to help you. I can kind of assure you that. At least I think. All right. So take a look at these two histograms. They are basically arranged exactly the same. The only difference is I'm noticing that data set B starts at a bigger number. So everything's bigger. So instead of starting at 30, it starts at 40. Distribution-wise, shape-wise, looks exactly the same, just bigger numbers. So take a look at this question. Looks exactly what I'm talking about. There's like 2 or 3 sentences of just does not help you at all. It's just explaining the include left, exclude right convention. You don't need to even read any of that. The question's asking, what is the largest possible difference between the mean of data set A and the mean of data set B? So we need to do something that's very similar to what's called optimization. So I'm going to show you guys, kind of help you understand what's going on in this problem via a trivial example. So let's say Adam has $5 to $8 and Betty has $9 to $12. And we want to know what's the largest possible difference between the amounts of money they have. Take a second, pause the video, see if you can figure it out. So the largest possible difference that they both, in the amounts of money that they have, I believe is 7. It's 12 minus 5 equals 7. You probably just use intuition to figure that out. But essentially what we did is we took the person with more money and had them make as much money as possible, and then the person with less money have as little money as possible. That way the numbers are kind of as far apart as possible on the number line, and then we subtracted them. So you see 12 and 5 are the farthest apart kind of numbers we get on the number line. So we maximized B. We took the biggest number possible, and we minimized A. We took the smallest number possible. This is analogous to the problem we're doing. I just gave the data sets names. So this is what we're going to do for this problem. We're going to maximize data set B, and we're going to minimize data set A. So one of the most important problem-solving skills you can try to develop in anything in life is to think of a simpler problem. So if you're not sure what these types of questions are asking you, just, I don't know, come up with a tiny data set, come up with a little silly example like this until you can kind of figure out what to do. And extrapolate whatever you come up with to the harder problem. So think of a simpler problem. Okay, so we have to let's label all the frequencies on top of the bars. That's always helpful. And we have to minimize A and maximize B. So, okay, the smallest number is the left one. So in the first box, it's 30. In the next box, it's 40. In the next box, it's 50. In the next box, it's 60. Now to maximize B, what we're going to do is, remember, we have to include left, exclude the right. So it's not 50 because they're integers. It could be 49.999, but because it's integers, it's 49. And the next one is 59. And the next box is 69. And the next box is 79. So now this question, now that we figured out what to do, all we need to do is calculate just basically everything we were doing in the previous skills. So we're going to calculate the mean of each of these. Not really going to go through this. I just did it on Desmos really quickly. So take a look at this. Hopefully I did it right. You should get for data set A, the mean would be 43.75. And for data set B, I got 62.75. And then if you subtract them, the largest possible positive difference. So do the biggest one in front. So 62.75 minus 43.75. You should get 19, and that would be the answer to this question. Great. Okay, another thing they ask about is they have you do some algebra questions on the mean equation. So the equation we've been working with this whole time, mean equals sum over n. What we're going to do is we're going to get sum and n by itself. So if we multiply both sides by n, we will get sum equals n times mean. And if we kind of swap mean and n, we will get n equals sum divided by mean. So you don't have to memorize these. I would just remember that you can do algebra on this equation to quickly solve for the other two things. I think kind of doing this at the beginning of the problem and then kind of plugging and chugging makes it a lot easier for me personally. So yeah, kind of the big problem with these is that so many kids, they don't think of mean as an equation. They think of it as just, oh, let me just add up all the numbers, divide by the number of numbers. That's not helpful. You need to put some kind of shorthand so that when you do come across an algebra question, you know what to do. Anyway, so we're going to do some problems kind of relating all three of these things. Oh, also for combining data sets, combining a data set is basically like you take all the numbers from one data set and you take all the numbers from another data set and just put them together into one big data set. So the sample sizes are additive. So if you had, let's say, 10 people and then 50 people, and then you combined them, you'd have 60 people, right? And similarly, sums are also additive. So if the sum of the first data set was like 200 and the sum of the second data set was 800, you could add them together and get 1,000. Now, really important, guys, means are not additive when you combine. Okay, you have to do some calculation using those formulas on the previous slide. So just make sure you understand that you combine data sets, you can just add up all the samples to get the total sample size, and you can add up all the sums to get the total sum. That's the idea. These aren't really equations you need to memorize or something. All right, so let's look at this problem. This is pretty much directly taken from a DSAT math question. So I just changed it up. So we've got two data sets and we're going to combine them. I see that they gave us n and they gave us the mean. So probably finding the sum is going to be helpful. Hopefully that makes intuitive sense. That's the thing we're missing, right? So we're going to do sum equals n times mean for both of them. So 45 caterpillars, mean of 9. So 45 times 9, that's 405. For data set B, we've got 55 times 12, which gives us 660. And remember what I said, guys, the combined sum, you just add them together. So the sum of data set C is 1065. And I mean, they told you n was 100, right? It says the lengths of the 100 caterpillars, but they didn't even need to tell you that. You could have did 45 plus 55 and figured it out. So just keep that in mind. But they saved us some work there. We didn't have to do that. So we get 1065 over 100, which is 10.65. So the mean of data set C is 10.65. So that would be our answer. Okay, let's look at another one. Okay, so this one has a sum and a mean. So I probably want to find n. So we're going to use the equation we talked about before, n equals sum over mean. So 847 over 11 gives us 77. And then 588 over 6, that gives us 98. Okay, so data set A has 77 caterpillars. Data set B has 98 caterpillars. And if we combine them, all the caterpillars from data sets A and data sets B, we can just add those two. So 77 plus 98 is 175. So there would be 175 caterpillars in data set C. We could also go and find the mean if we wanted to. You would just need to find the total sum. Great. Okay, this one's really confusing. I wasn't really sure where to put this. I figured this was a good place since we're just talking about equations and stuff. So it says we have 8 integers, and there's kind of data set A actually has 9 integers, so 1 is missing. So I'm just going to call the missing one x. And we can write an expression for the mean by doing sum over n. And you should get 544 plus x over 9. And if you read the question, it says that the integers have to be less than 79. Okay, so x has to be less than 79. But it also says the mean is an integer that is greater than 68. Okay, so the current mean is 68, and we want it to be bigger. So the number we're adding, in order for the mean to go up, must be bigger than 68. So x has to be somewhere between 68 and 79. So it can really be, your kind of potential candidates are any of these numbers, 69 all the way up to 78. So how are we going to figure out which one it is? Well, notice they said the mean of the data set has to be an integer. So we're basically just going to kind of guess and check these guys until we get one that gives us a whole number. So if you do that, you should find that the only one that works is 77. If you plug in 77, you should get a mean of 69, which is an integer. So the largest integer, and 77 is bigger than all those numbers in the data set. So the largest integer is 77. So I went over this in my Desmos video. These questions, you can use Desmos to kind of like graph the missing value. And then I basically just started guessing and checking means. That's the y. So I was like, mean is 69, mean is 70, mean is 71. And you kind of see once the mean gets to 70, 71, it's not going to cross the red in that little blue box. So it's just not going to happen. It's got to be a mean of 69 and a missing value of 77. Anyway, I think this is situationally helpful knowing how to do all this. Not too important though. All right, so we already talked about 2 big statistical measures. We talked about mean and median. Mean is what you think of as the average. That's probably the word you use in school. Median is the middlemost number. But there's 2 what's called measures of spread, which we haven't really talked about up to this point. Range, which is just max minus min. That's the biggest value minus the smallest value. And standard deviation, which is put maybe a little bit too simply, roughly speaking, the average distance from the mean. So let's talk about problems we might see with those 2, range and standard deviation. Okay, so range, remember we said, is max minus min. That's something you definitely want to write down, that equation. It's often straight up just a fact up question. If you know this word, you get it right. If you don't, you get it wrong. So the biggest value is 23, and the smallest value is 5. So we're going to do 23 minus 5, which is 18. So the range would be 18 for this data set. That's it. Okay, standard deviation. Again, put very simply, is proportional to the average distance from the mean. So if the numbers are far away from the mean on average, it's got a high standard deviation. And if they're close to the mean on average, it's got a low standard deviation. So let me show you an example. So I don't even need to do any calculations. This data set is symmetrical. The mean is 5. By the way, this is called a dot plot. It's very, very similar to a histogram. Very, very similar to a histogram. It's just instead of a bar, you've got dots representing how many data points there are. So I don't even need to do any calculation. I see that the mean is 5. So I'm going to put a little pivot right where 5 is. And you see that a bunch of those points, those 3 there, those are 0 from the mean. They are very close to the mean. But if you look at these guys, they're 1 away from the mean, so not too far. And then if you look at these guys on the outside, they're 2 from the mean. So let's just give you a rough idea of like kind of what's going on when standard deviation is computed. You don't need to worry about this too much. We'll talk about what we do need to worry about in a second. But you kind of see that this has a relatively small standard deviation because so many of those data points are either right on top of the mean, 0 away, or just 1 away. So they're pretty much as close, almost as close as can reasonably be. So this probably has a small standard deviation. Anyway, so do you need to calculate standard deviation? No. Here's the Desmos command if you want to know it, just because I figure someone's going to ask me in the comments. This is never going to be the exam. Kind of useless. I don't really think you should bother knowing how to do it, but just in case you're curious, the Desmos command is stdev. But they don't expect you to know how to calculate standard deviation. They only want you to know how to compare it between usually 2 data sets. So it'll just be a multiple choice question, and you'll figure out which one's got a higher standard deviation, if they're higher, lower, or equal. That's it. So we'll go over how to do that now. So if a data set is more spread out, it has a larger standard deviation. If a data set is less spread out, it has a smaller standard deviation. That's it. Don't even think about distance from the mean. Just try to eyeball the spread. That's all you got to do. And if they have the exact same spatial orientation, like they look exactly the same, then they have equal standard deviations. Okay, so let's look at these 2 data sets. Do you see how despite the green ones being bigger, they are arranged spatially exactly the same? You've got 1 dot, and then right next to it, 2 dots, and then right next to it, 3 dots, and then right next to it, 2 dots, and then right next to it, 1 dot. Because they're arranged exactly the same, they're not spread out differently, they don't have a different look or anything like that. These guys have this same standard deviation. So this is an example on 2 having equal standard deviations. So this is what I mean when they have exactly the same orientation. I mean they literally look exactly the same. Okay, let's look at another one. So I see that these guys are roughly symmetrical. Just for the sake of teaching, let's mark the mean with a pivot at about 5. And I think that data set A, it's got a lot of numbers either right on that mean or really close to it, but B's got a bunch more that are farther away, like the ones on 3 and the one on 7. So I think B is more spread out. So that means dataset B has a larger standard deviation than dataset A. Okay, let's keep going. All right, for this one, my picture isn't perfect. It was kind of hard to fit this all on one slide. And maybe at first glance, these look the same. But do you see how in A, it's actually going by 2? So instead of it's got 1, but then nothing in the next grid marker, and then it's got 2, and then it's got nothing in the next grid marker, whereas B is one after the other. So dataset A is actually more spread out. So dataset A has a larger standard deviation than dataset B. Okay, let's look at this one and this one. Okay, these guys I do think look exactly the same. We've got 3, then 2, nothing, 1, nothing, nothing, 1. Looks exactly the same. So they have the same standard deviation. They are equal. Great, let's keep going. So they'll almost always, when they ask you these questions, give you a dot plot or a histogram, and as you kind of saw, really all we have to do is just look at it. They could give you frequency tables or lists, in which case you got to kind of visualize in your head where the numbers are a little bit. But remember to keep in mind, regardless of what you do, that you just remember spread as you're answering the question. How spread out are they? Whichever one looks more spread out has a higher standard deviation. Okay, maybe I should have done this at the beginning, honestly, but this is we're going to go over what's called a bar chart. So a bar chart is any statistical graph which displays categorical data using bars. So this is not the same thing as a histogram, and there's no frequencies. These are just glorified lists. These are essentially just lists. So each set of bars represents a list. Okay, so in this one, it's not like values on the x-axis and frequencies on the y. The values are on the y, and then the x-axis is categories. So that's just a list. So we would just write that down as like 32, 23, 24. You guys see what I'm saying? And then do mean and median like we were doing at the very beginning of the video. This is a more complicated one, but you kind of notice the common theme here, and that if you see categorical variables, in other words, words on one of the axes, it's probably a bar chart and not a histogram. Okay, let's keep going. All right, side-by-side bar chart. That's actually the kind we were just looking at on the right. This is basically just two lists. So the blue list would be like 1, 8, 1, 7, all with commas. And then the red list would be 1, 4, 3, 2. And maybe the question would ask you to compare the means or compare the medians or something like that. Bunch of things they could ask you about this. Somewhat self-explanatory. Okay, so look at this. I made this graph from real data I found online. It's about movie theater chains and how many screens they have. So I'm just going to write it down as a list before I answer the question at all. I feel like that's helpful. So 11, 5, 2, 6, 7. Hopefully you're kind of noticing these are not in order. So a very common mistake is people would go, what's the median? And they'd go, oh, it's the one in the middle, 2, right? But you guys see now that that's not correct. Remember, when we're finding the median, we have to put them in order first. Anyway, you can use skill 1 and 2 at the beginning on your own. Just for the sake of simplicity, I'm just going to type these into Desmos. You can type it in using square brackets to make it a list. Kind of save you some typing, so you don't have to type in 11, 5, 2, 6, 7 twice. You could just write mean of A and then median of A. So the mean is 6.2 thousand screens, and the median is 6,000 screens. Great, that's it for bar charts. What is an outlier? Okay, so an outlier is a data value that differs significantly from the other values. So that's a little subjective, but the SAT is always going to make it super obvious. Okay, so like if you were looking at a chart, you kind of see that those two black dots on the edge are really far away from the majority of the values. Those are outliers. We don't need to do any calculation to verify that. It's just they make it obvious for us, right? So just like how you don't need to know how to compute standard deviation, you don't need to know how to compute if something is an outlier. It will just be obvious. Okay, so for the sake of simplicity, I'm going to call these guys small outliers because they're smaller than most of the numbers. And I'm going to call these guys big outliers because they're bigger than most of the numbers. So you'll get questions where they add or remove an outlier. So if we add a small outlier, like that number there, the mean will go down considerably. The median will go down a little bit, or it will stay the same. You don't know which it's going to be, so you have to check. You actually have to compute it, but you don't have to compute the mean to know that it's going to go down. You know it's going to go down because the outliers pull the mean towards them. All right, for adding a big outlier, so let's say we have this data set and then we chuck in this number. The mean will go up considerably because that outlier pulls the mean towards it. And the median will either just barely go up or it will stay the same. You have to check. If these are lone outliers and they are the new max or the new min, the range will go up a ton. Think about it, right? If you look at the range of that compact data set, it's from like 60 to 45. And then on the left one, it was like 19. So now it's going from 60 to 19. That is way bigger. That's like 2 or 3 times as big. So the range is going to get affected a lot by outliers if they do indeed become the biggest or smallest number. Okay, great. Now, this is kind of redundant, but if you take away a smaller or big outlier, everything we just did, the same happens, but now it's just the opposite. So if you remove a small outlier, now your mean will go up considerably, and the median will go up a little or stay the same. And if we remove a big outlier, the mean will go down considerably, and the median will either do the same thing the mean does or stay the same. Again, you have to check, and the range will go down a ton if that was the biggest or smallest value, and the max or min changed a bunch. So yeah, again, pretty much the same as what we just did on the last slide, just the opposite. So okay, so let's look at this example. The list above gives the heights of 6 children. A 7th child with a height of 70 inches will be added to the group. Which of the following correctly describes how the mean and median of the group? Okay, so let's put that guy in there, 70. He's a big outlier, and we added him. So we added a big outlier. So the mean is going to go up for sure. Anything that says the mean is not going up, we can cross out. So that one and that one both say the mean will decrease. Now we have to figure out if the mean will increase or stay the same. And in this one, I just used Desmos to do it really quickly. The median did go up. It went up from 52 to 53. So we're going to select answer choice A. So notice, guys, it's not asking you, did it go up a lot? No, it's just asking you, did it go up at all? So if it went up from like 52.4 to 52.6, that is increasing. So that would count. So this one's answer choice A. All right, another question you could see, if you add or remove a lone outlier, like one at the very edge, it's a max or min, right? Kind of like all the ones we've been doing. Range changes the most. Then standard deviation. Then not far behind that, mean. And you've probably noticed at this point, guys, median changes the least. So if I chuck in an outlier and I said, what increased the most? You would say the range. And if I said, what increased the least? You would say the median. So the range is heavily influenced by lone outliers, and the median is very resistant to change. It's not heavily influenced. It's very resistant to change. Okay, next up, we have something similar but kind of different. It's called modifying statistics. There's probably there's probably more ways. There's probably a bunch of different things they could ask you about changing statistics, and you'd have to kind of think on the fly. But I'm just going to show you what I think are kind of the 3 most common and important, at least out of what we haven't already covered. So something I've already seen on the DSAT, taking them myself, is adding or subtracting a positive number. So let's look at an example. Let's say we have 1, 2, 3, 4, 5, 6. And the question says we're going to add 8 to each number. So our new data set is 9, 10, 11, 12, 13, 14. And you might kind of notice all we did was shift it. If we had a dot plot, all we did was shift it. We just moved it. So the spread is going to stay the same. But the center, the mean or median, will increase or decrease depending on if we added or subtracted. So because we added 8, the mean and median both increased. I didn't need to do any calculation to know that. You could if you want, but I didn't need to do any calculation to know that. I can just figure that out from my knowledge of statistics. All right, let's go on to the next one. So another case that you might see is if you multiplied each number by a positive number. So let's say we had 1, 2, 3, 4, 5, 6, and we're going to multiply each number by 7. We now have this 7, 14, 21, 28, 35, 42, 49. And as you might be able to tell if you made a dot plot, these numbers are now pretty far apart. So the spread would increase, and the center, the mean or median, the mean and median would increase as well. They would decrease if, say, you multiplied by a fraction. So like, let's say you took all the numbers in data set A and multiplied them by 1/2. Then they would be closer together and the mean and median would be smaller. So great. Okay, let's look at a problem. It says dataset B is created by adding 13 to each of the values in dataset A. Okay, so let's see, what did we talk about for adding a number to each number? We said that the spread will stay the same. And we said that the center will increase or decrease. So the median, because we're adding 13, not subtracting, the median will increase. So we can get rid of B and D because they say that they both say that the range is changing. We just established that the range is going up. Or sorry, that the range is staying the same. And we want the one that says the median will increase. So for dataset B, the new dataset, it'll be greater. So that's answer choice C. So you could go and do the calculation, but you see you don't have to. It's like if you just understand that, oh, adding and subtracting a number to every number does not affect the spread, you're good. But multiplying a number does affect the spread. All right, another case that I've seen like once or twice before that I feel is worth mentioning is if you subtract a number to the left of the median and add it to the right of the median. So let's say I have 6, 7, 8, 9, 10, 11, 12. The median is 9. And the question says subtract 4 to every number to the left of the median and add 4 to every number to the right of the median. So we now have 2, 3, 4, 9, 14, 15, 16. So these numbers are now more spread out. So the spread will increase. And the center, it's still symmetrical. We have the same sum. We have the same mean and the same median. So the center will stay the same. Okay, so we're going to, each number less than the median is reduced by 5. And each number greater than the median is increased by 5. Which of the following correctly compares the medians and standard deviations? Okay, so as we talked about, the spread is going to, the median is going to, the center is going to stay the same. So C and D are both wrong because it says the median is getting bigger. And we said the spread, because we're basically just taking the numbers and pushing them apart, right? So the spread will increase. So we want the one that says the standard deviation is greater. So that's answer choice B. Again, there's a bunch of different tiny variations of this they could ask you, but those are probably what I think outliers. And then those 3 cases we just covered, that's probably pretty much the vast majority of what you're going to see. So, all right, now we're going to do a box plot. Take a look at this data set. So box plot is we're looking at it. It's called a box and whisker plot as well. Really, all you need to know is that the leftmost tick is the min, the right whisker is the max, and the line in the center of the box is the median. That is all you need to know. I'm just going to tell you what these other ones are called just in case you're curious, but it's not going to be on the SAT. That left kind of vertical line on the left side of the box is Q1, and that right vertical line on the right side of the box is Q3. So, like 95% of the time you see a question like this, they're just going to ask you the range and the median. So the median, you just look at it, it's 17. It's literally a fact check question. It's like, if you know that line in the middle is the median, you're good. The range, as we talked about, is max minus min. So for this one, it's 28 minus 5, which is 23. Okay, so the other thing you might want to know about this is that each piece of the chart contains 25% of the data values. So let's look at this example. Do you kind of see, if I put the numbers in those boxes, in those like kind of chunks of the chart, there's 8 numbers, and there's 2 kind of in each section. Well, 2 divided by 8, that's 25%. So you see, each of these pieces does contain 25%. So I could maybe, I've almost never seen this, but I could see this in a question being like, for example, oh, like from 10.5 to 28, what percent of the data points are in between 10.5 and 28? And you would go, okay, that's 3 pieces, 75%. That's it. So those are really the only 3 things you need to know: median, range, and that each piece of the chart makes up 25% of the data. So that right there, between those 2 purple, that would be 75%. Okay, common misconception is they'll often have trap answers talking about like mean or standard deviation. Box plots don't tell you about that. They don't tell you about mean or standard deviation. You can maybe guesstimate how spread out a data set is, you know, by looking at its box plot, but you're not going to be able to come up with anything conclusive. So do not, if you see an answer choice for a box plot question talking about mean or standard deviation, just cross it off right away. It's probably not right. So here's an example. What they'll do to make this a little bit harder is they'll give you 2 of them. So like a side-by-side box plot. So the median, we look at the line in the bars, the line inside the box. The median of the top one is 12, and the median of the bottom one is 17. For the range, we look at the very ends of the whiskers. The top one is 28 minus 3 equals 25. And the bottom one is 28 minus 5 equals 23. So maybe you'll get a question being like, which one has the bigger median? Which one has the bigger range? Or maybe you'll have to find the 2 medians, and they'll be like, oh, what's the difference between the 2 medians? And you would do 17 minus 12 equals 5. Again, don't let that confuse you. Just tackle each box plot individually and then answer the question. That's what I would do. Okay, that's pretty much it for the slides. I just want to do a quick kind of disclaimer. We still haven't covered everything that's on statistics. You see, this takes forever, right? So in the 3rd video, we did confidence interval and margin of error. And in this video, we did basic statistics. So there's still 2 more topics we haven't done, which is table probability. That'll be a short one we'll do in the future. And statistics conclusions. So basically any statistics conclusion that does not have to do with margin of error. So for example, experiments and cause and effect, like stuff like that. That is just very, very rarely on the DSAT, it seems anyway. So we're still not done yet, but we've got more to come. But we've definitely covered the brunt of what you'll see. So that's good. Okay, it's time for the final review. Remember to download the free final review worksheet using the link in the description. Try to complete the worksheet yourself before watching the rest of the video. And I highly encourage you to ask relevant questions about this topic in the comment section. Okay, let's switch to the whiteboard for the final review. Okay, so for this first question, we're going to do mean equals sum over n. I see that there's 1, 2, 3, 4, 5, I think 6 numbers. So n is 6. 9 plus 26 plus 11 plus 3 plus 4 plus 7. That should be 60. And 60 divided by 6 gives us 10. So that would be the answer for that one. Now this next one, it says what's the median of the same list. So first thing, if we're going to do it totally by hand, we have to put it in order. So I think it's 3, 4, let me just do it up here. 3, 4, 7, 9, 11, 26. I think I did a good job at that. Again, there's 6 numbers, so we're going to do the position of median is equal to n plus 1 over 2. 6 plus 1 over 2. That's 3.5. So we have to take the average of the third and fourth number. 1, 2, 3, 4. So that's these two. So the median is equal to 7 plus 9 over 2, which is 8. And I believe that is the answer. Let's go over to Desmos and see how we could have done it on there as well. Okay, looks good. And just give me 1 second. Okay, looks good. All right, let's type it in as a list. A equals square bracket 9, 26, 11, 3, 4, 7. And if you guys didn't know, you can, I can't do it that much because I have it set really weird, but if you can drag this and make the box wider to make it easier to see what you're typing. Okay, so I'm going to do mean of A, I get 10. I'm going to do median of A, and I get 8. Okay, seems like we did a good job. Let's move on to the next question. Okay, this is the mean of a frequency table. So we're going to do mean equals sum over n. And I'm just going to type that all in the calculator in a minute. The n is, let's see, 2 plus 5 plus 7 plus 3 plus 8 plus 4 plus 1, which is 30. So again, guys, we add up the frequencies to get n. And the sum, we're going to multiply and add those guys in the chart. So why don't we go to Desmos for that? So I'm going to make this as big as I possibly can. 3 times 2 plus 7 times 5 plus 12 times 7 plus 14 times 3 plus 17 times 8 plus 24 times 4 plus 51 times 1, all over 30. And we get a mean of 15, so why don't we write that down? That'll be our answer for question 3. Okay, let's go back over here. Now we're going to do the position of the median is n plus 1 over 2. N we said was 30, right? So 30 plus 1 over 2, which should give us 15.5. So we need to take the average of the 15th and 16th. And now I'm going to add up the frequencies to find what those numbers are. 2, that's too small, got to keep going. 2 plus 5, too small, got to keep going. 2 plus 5 plus 7, that's 14, still too small. 2 plus 5 plus 7 plus 3, that is 17. So both the 15th and 16th are in this row. So that means the median is 14. Okay, great. What is the minimum? Okay, that's just the smallest value. So that is 3. Let's put 3. Maximum, that's just the biggest value. So that's 51. And range, we talked about max minus min. So that's 51 minus 3. 51 minus 3 is 48. Okay, I think that's our answer for that one. Looks good. Okay, now we got a histogram asking very similar questions. Why don't we first, just to make it a little easier, label the tops of the bars of the histogram. So this one's 1, 2, 4, 1, 2, 4, and then this one's 1. And if you added up all those red numbers, you should get 15. But you didn't need to do that because they told us that there's 15 students, so that is your n. So I'll just write that down immediately on my scratch paper. N is 15. And now we're going to do mean equals sum over n. So all that nonsense multiplying and adding over 15. And we'll just do that on Desmos just to save me some stress here. Make this as big as I possibly can. Okay, 1 times 74 plus 2 times 77 plus 4 times 78 plus 1 times 79 plus 2 times 80 plus 4 times 81 plus 1 times 82, all over 15, which gives me a mean of 79. Great. Let's go back over here. So we get a mean of 79. Now for this one, we're going to do the position of the median is equal to n plus 1 over 2. So 15 plus 1 over 2. 16 over 2, that's 8. So we have to find the 8th value. That's going to be our median. So we go back up here and we add cumulatively until we hit 8. 1, no, 1 plus 2, no, 1 plus 2 plus 4, no, that gives me 7, not quite. 1 plus 2 plus 4 plus 1, okay, that is right here. So the 8th one is a 79. So the median is also coincidentally 79. Well, that's our answer for that one. Okay, and range, we're going to do range equals max minus min. And let's see, the maximum is 82, and the smallest bar is 74. So we're going to do 82 minus 74. And that should give us 8. Okay, great. All this nonsense about the include left, exclude right convention, we don't need to worry about that. We know what that is. 16 integers. These are just the same charts we used before, but it's a different question. So we want the smallest possible value of b over a. So when you have a fraction, guys, and you want to make it small, hopefully this makes kind of intuitive sense. You want the top to be as small as possible. And you want the bottom to be as big as possible. Think about it. Dividing by a big number makes it really small, right? So hopefully that makes kind of intuitive sense. Come up with an example with some numbers if you don't believe me. All right, so B, data set B, and it's asking about means, not medians. It's asking about means. So we're going to maximize A, and we are going to minimize B. Okay, so A, so the biggest number is 39. Then in this one is 49, 59, and 69. And then the smallest for B, so the leftmost one is the smallest, so 40. 50, 60, and 70. And for both of these, n is 16. Okay, now we just need to figure out B and A. So let's go to Desmos. Let me pull the chart up. Okay, so A is, okay. Oh, I didn't write the numbers on top of the bars. 3, 6, 5, 2. 3, 6, 5, 2. Great. Okay, we're in business. Okay, 3 times 39 plus 4 times 49 plus 5 times 59 plus 2 times 69 over n, which is 16. And B is 3 times 40 plus 6 times 50 plus 5 times 60 plus 2 times 70 over 16. Okay, so A is 46.625 and B is 53.75 for the question they're asking us, right? And we're now going to do, we want the smallest possible value of B over A. So let's do B over A. Okay, I think I might have did something wrong. Let me just double check. Okay, yep, I had a 4. I just typed it in wrong. I had a 4 where I should have had a 6, like up here. Okay, so I was wrong. A is 52.75 and B is 53.75. And B over A, we get 1 point, rounded to the hundredths, that would be 1.02. We round up because of the 8. You see, if I made this a fraction, the reason why I asked you to round here is because if you made this a fraction, this would not fit in the Blue Book app. It's too many characters. 215 over 211, too many characters. So let's go to the 100th. That's 1.02. Since the question told us to do that. If it didn't tell us to do that, we would just keep typing until we run out of room. Okay, so let's go back to the board. So we get 1.02. That is our answer. Great, let's keep going. Okay, mean is equal to sum over n. So that means that the sum is equal to n times mean. Because for this question, I see they give us n and the mean. So we probably need to figure out the sum. That just kind of makes intuitive sense. So the sum is equal to 42.25 for the first data set, which is 1050. And then for data set B, we're going to do 38 is n, and the mean is 45. So 38 times 45, that gives us 1710. Okay, so for data set C, the sum is 1050 because when we combine, the sums and the samples sizes are additive. So 1050 plus 1710 gives us 2760. And then for n, we're also going to add the n's, which is 42 video games and 38 video games. That should give you 80. And now to find the mean for dataset C, we're going to do sum over n, 2760 over 80. And we should get 34.5. Which, if you're actually writing it in real life, in America, we would say that's $34.50, but they don't have you write, dollar signs and stuff like that in the Blue Book app, so you don't need to worry about that. So the answer is 34.5. Great, let's keep going. Okay, this one wants us to compare the standard deviations. I'm not even going to look at the answer choices. I see that these guys are more spread out. They go from like 2 to 8. And the other one is more packed together, 3 to 7. So more spread out means it's got a higher standard deviation. So I want an answer choice that sounds like they are picking, that sounds like dataset B has a higher standard deviation. I think that is this one. The standard deviation of dataset B is larger than A. So that looks good to me. That could have also conversely said the standard deviation of dataset A is smaller. Just be very careful. They might phrase it differently from how you phrased it in your head. So just keep an eye on that. I don't think I've ever seen one of these questions where this is the correct answer. I've never seen that be right. You can almost always tell just by looking at the picture that they provide. Great, let's keep going. Okay, this is real, by the way. This is real data. Okay, I'm giving you an insider's look. We're going to come back and talk about this because some of these numbers are shocking to me. Let's answer the question first. So first things first, I noticed that each big tick is 10, and there's 5 spaces. So that means 10 divided by 5 is 2. So each little tick is 2. Okay, so 20, 22, 24, that's 24,000. That's also 24. That's 30, 32, 34, and that looks like it's just past 34. So this is 35. This is 10, 12, 14, and then one past that, so 15. And then this is 30, 32, 33. And again, guys, when you go to do the median, it's not just the one in the middle. You have to write them down and put them in order. So let me just write them down, and then we already did that. So if you want to do it by hand on your own, I leave that to you. We already did that at the beginning of this worksheet. So I'm just going to use Desmos. Notice how, too, it says in thousands, so we don't need to change it to like 24,000, 35,000. If it didn't say that, we would need to convert it by multiplying by 1,000. But because it says that, we don't need to worry about the units because the units match what's in the chart. Notice that? See how it's the same in the chart? Okay, let's go to Desmos. Why don't we make list A? Let's do T for tutorlearning. So bracket 24, 24, 35, 15, 33. And we're going to do the mean of T and the median of T. Okay, so for the mean, we get 26.2 thousand. And for the median, we get 24,000. So you see a lot of people, if they saw that median question, they would have just looked at the one in the middle, USA, and said 35, but that is way wrong. You have to, if you're going to do it by hand, you got to put them in order first. They're not in order. Okay, guys, these are my lifetime views by country as of New Year's Eve. And it's like, now everyone in these top 5 countries is great, but I just want to point out something that shocked me is like I looked up the populations of these countries. Nepal is like way smaller population than basically every other country on this list. And Nepal, and again, how many of these views in the US column are like my friends and colleagues and myself, like going in the comment section? So I don't even think US has the most views. I think Nepal has the most views if you think about it. And like, I've again met many people from a lot of these top countries through the community, and it's been amazing. So thank you. But you know, special shout out to Nepal. Like, you guys are putting in work watching my channel. I don't know what it is, why you guys have such a high tutorlearning view per capita, but you do. So anyway, thank you guys so much for watching. Okay, question 16. So for this one, we might have to do some calculations. So why don't I first write the numbers on top of the bars? Did a terrible job trying to fit this on the screen here. Okay, 1, 4, 3, 2, 3, 4, 2, 1. And if we added up all those red numbers, 1 plus 4 plus 3 plus 2 plus 3 plus 4 plus 2 plus 1, we would get 20, but it kind of doesn't matter because they told us there's 20 students in the class. Anyway, so they tell you that the student with the grade of 96 is getting kicked out. So we're removing a big outlier. So let me kind of put an X through this guy. And we are removing a big outlier. So remember we talked about, guys, when you remove a big outlier, no matter what, you don't have to do any calculation. The mean is going to go down. So anything that says the mean is going to go up, we're going to cross out. So the mean, this one says the mean is going up, and this one says the mean is going up. So those are both out. A and C are out. For the median, remember, guys, we can't just use intuition. We have to check it. Because sometimes it will stay the same, and sometimes it will just barely slightly change. So we're going to first calculate it, including that guy on the right. So we're going to do it with n equals 20. And if I do that, I get a position of the median is 20 plus 1 over 2, which is 10.5. So we have to find the average of the 10th and the 11th. Now, if I go and like cumulatively add the frequencies, you know, like we've been doing, add, and then we stop when we hit it or we exceed it, so greater than or equal to. So 1 plus 4, too small, plus 3 to that, 8, too small. Now I'm looking at the fourth bar, plus 2, 10. Okay, so the 10th is in this bar. And then if we add one more, 2 plus 3, we get 13. So the 11th must be in the next bar. So the 10th value is a 79, and the 11th value is an 80. So the median is, you add those up, divide by 2. 79 plus 80 divided by 2, I get 79.5. So that's the old median. Now we're going to do it where we remove that guy. So let me also just erase this. So n would be now 19. So the position of the median would be 19 plus 1 over 2, which is 10. And if we add and go do that again, we see that the 10th value is still here. And we would get a median of 79. So we got a little unlucky here. The median did just barely go down. If we had more numbers in that box, in those boxes in the middle, it wouldn't have changed at all. So the median just coincidentally did go down for this one as well. Remember, you have to do the calculation. It went down just a tiny bit. So both the mean and the median will decrease. Though the answer totally could have been D for a different, slightly different graph, slightly different histogram. Both the mean and median will decrease. Great, let's keep going. Okay, so this is a modifying statistics question. We're going to subtract 6 from each of the values. Okay, so adding or subtracting, the spread stays the same. And the center, because we're subtracting, it's getting shifted to the left. So the center will go down. It will decrease. So is there any that say the range changes? B says that, because that's spread, right? And range, and D says that. We want one that says the spread or the range is the same, equal. Okay, so looking at answer choice A, this one says the median of dataset B is equal, so that is wrong. So I think it's got to be C. So the median of the new dataset is less, smaller, it got smaller. And the range stayed the same, because when you add or subtract a number to all the numbers, all you're doing is just shifting it left or right. So the center moves, the position moves, but the spread is unaffected. Great, that looks good to me. And I mean, even if you weren't sure, just like, you know, I don't know, write a simple data set like 10, 11, 12, 13, and compute it with Desmos or something. Perform the transformation and then compute it with Desmos. All right, I think there's some more. Great. Box plots. Okay, let's look at this. What is the positive difference between the medians? Okay, so the medians, we look at the line inside. So the median for the first one, for the red one, is 15. The median for the green one, no, it's kind of hard to tell, guys. I'm pretty sure it's 18. Let's write that. Median equals 18. So the positive difference, just do big minus small. So 18 minus 15, which is 3. Now we're going to do the ranges. So that one, that one, that one, and that one. So the red one has a range of 30 minus 4, which is 26. And then the green one has a range of 24 to 7, which is 24 minus 7 is 17. Okay, so it's asking for the product of the ranges, so we'll just multiply them together. So the product is 17 times 26. Let's see what that gives us. 442. And it says in the second box plot, the red one, what percentage of the data lies between 4 and 15? Okay, so 4 and 15. So that's that marker to this marker. That is 2 pieces of the box and whisker plot, the box plot. So each piece is 25%. So 2 pieces would be 50%. So that is 50% of the data. Okay, let's go back to the slides. Okay. Thank you so much for watching my video, everybody. I worked really hard on this one. Please comment below your thoughts on the video and worksheet. Did you find them helpful? Be sure to like the video and subscribe for more digital SAT math content. And as always, if you're interested in my tutoring services, my website will be linked in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.